JavaScript, particularly something called JS, which I'm excited to learn what that is. Can you not hear me back there?
I am on the mic.
I thought my voice scary. Go ahead.
You can adjust it if it's not.
I'm getting closer, further away. Okay, is this good?
Yeah.
Right here? Okay. So hey everyone, my name is Reece. I'm a software developer at Click. Like some of you may have been to Click before, sometimes the React meetups are there. So we actually, our team is actually hiring. We're doing some pretty cool stuff. We're doing React. We're doing Redux, all this cool stuff. So come talk to me after if you're interested. So that's enough about me. I'll move on to, I'm going to be talking about benchmarking JavaScript with React. As Eric quickly mentioned earlier, so I wrote a little web application that you can benchmark JavaScript in, and I'm going to talk about that more about that later. But first, has anyone heard this quote? Hands up. Any hands? Well, a few people are like, sometimes I've heard micro optimization or just optimizing is bad. So not a lot of people, but anyways, maybe I should have put this in. But so the full quote, it's often not quoted, is we should forget about small efficiencies, say about 97% of the time, and then he does go on to say premature optimization is the root of all evil, yet we should not pass up opportunities in that critical 3%. So this is written by Donald Knuth in 1974, way back. In a book about structured programming in go-tos. That's not super important. But I often think that I hear this misquoted a lot. We shouldn't premature optimize. We shouldn't optimize, or if the optimization is too small, we shouldn't do it. So what I think this means is it's not that we shouldn't optimize code or we should always optimize code. But I think I do it when it makes sense. So in critical parts of the application, of your application that you think are getting hit a lot and they need to be performant, then maybe take a closer look at optimizing. And you don't need to necessarily always wait until there is a problem to start optimizing. And I think a lot of people think that you should just write code and then there's a problem and then you optimize. But also don't always optimize, because that takes a lot of time. Is this too small? Don't sacrifice simplicity. So unless it's essential to your application working, I would say try to keep everything simple. Actually, I really like the quote, your code spends most of its time being read by humans. Always keep your code nice and simple, easy to read. And when you're benchmarking or optimizing, always measure. So measure before and after. Make sure what you're doing, what you're optimizing, is actually improving. Because I'm going to get to it in a bit. Sometimes it's not obvious. You might write, you're like, oh, I'm going to rewrite this and it's going to be more performant, but you need to measure before and after because sometimes it's not. All right. So I wrote jsperf.com. I actually wrote this about 3 years ago. In Angular 1.3 or something, with Bootstrap, back when that was a thing. But recently, I just started using it more, and I'm like, you know what, I should add a bunch of stuff to it. So I rewrote it in React, and a bunch of cool tech that I'm going to talk about after I demo it. Yeah, let's just show it off. Okay. So, wow, that's just perfect. Is that too small? That's pretty small. Okay. So I just threw this together in about 2 weeks for this talk. This is actually live on jsperf.com, so it's jsprf.com. Please try it out, and it's up on GitHub. I'll post that at the end, so if you want to contribute or if you find any issues, let me know. And if we run into any bugs, it's still pretty fresh. So essentially, what we can do with JSperf is we can write little snippets of JavaScript and compare them against each other, compare how performant each one is to each other. So we see on the left side here we have a list of our scripts. So we have you can run a setup script that can set up all your functions, all your common functions, your variables, all that stuff. And then we have the scripts that's actually going to run and be compared against each other. So if you go to jsperf.com right now, you'll actually see this. This is just a default kind of getting started benchmark. And what it's doing is we have a string, hello world, and we are checking if the string has the character O in it 3 different ways. It's not the most exciting benchmark ever. I wouldn't recommend actually, trying to optimize such a small thing, but it's actually kind of neat. And so in the middle here we have our actual code editors, and I am using the code editor that VS Code uses. So I could do cool stuff like Eric equals awesome, right? And then I could do, and it's not working right now for some reason. So what if I do? Nope, of course it doesn't want to do anything. Okay, refresh. I've had it open for a while. Exactly. And now it's not loading. Great. Okay. So, maybe my network's down or something? Uh-oh. Okay. No internet. Okay, it's not my fault. I'm gonna get to this thing now. That's weird. All right. This is going well. Okay, while I try to load that, so I actually am using something called Monaco, which is the editor used by VS Code. So you can use IntelliSense as refactoring capabilities, go to symbol, all that cool stuff. Why is this not working? Okay, hold on. Let's try to start this out. Google. Nothing. All right, I'm going to try.
Turn off Wi-Fi, turn it on again.
Okay, I'm going to turn off Wi-Fi and turn it on again, but I will disconnect from this, I think. Yes. Okay. And Wi-Fi back on. Okay, we're connected. I will try to refresh it. Okay, that worked. I'm just going to reconnect to the TV here. Sorry about that. Hey, cool. All right. So let me try that again. So if I do, there we go. Get some autocomplete stuff here. I can do Eric equals awesome, and if I try typing Eric, it's gonna try to autofill that for me, and I can see it knows that's a const, and the const is set to awesome. Just cool stuff like that, right? Also, if I wanted to test, let's say I wanted to test Lodash underscore Axios, I wanted to bring some dependencies in here, I can dynamically import dependencies. This is actually super cool. I'm going to talk about that a little bit later. But let's say I just wanted to import Lodash here. I just do that. And of course it doesn't work because of the network or something. Great. Okay. I swear this normally works. Okay. So we would see this loading, and actually it must be. Hold up. Let's try this again. Underscore.
So I submit now.
Pending. Yeah, this network just keeps dropping. Super weird.
No offline mode?
No offline mode. It's not progressive yet. Okay, so it didn't find them, but you could do that. Okay, so I can still do this next part. So I'm just going to run this benchmark. So over in the right pane, I have the results of my benchmark. I'm just going to run that. And I'm actually using a benchmarking library called benchmark.js. And so it takes each one of these pieces of code, runs it a couple thousand times, measures the performance, and then it spits out here how many operations per second we're getting. And then once it's done, it'll tell us, okay, the fastest one is the one in the middle here, and it's 35.45 times faster than string.match. So is it, can you guys read that?
No.
It's still pretty small.
It's pretty small.
Okay. No, I should be right. All right, thanks. Okay. What's in here is not super important, but we can just see that it is actually doing the same thing. They're all 3 different pieces of code trying to do the same thing, but this one is actually way faster, 35 times faster. than these regex expressions. That's not super useful, but we can see here that this code isn't necessarily a lot more complex, and it's just easy to use that instead of the other ones that'll be a little faster. Cool. All right, let's jump back into the slides. So why I did this is because I'm I am obsessed with performance. I try not to spend too much time just benchmarking every line of code, but and you shouldn't probably. But there is another website called JSPERF, and that's been around for forever now. And I used to use that a bunch. And that went down for like a year because you can actually save your benchmarks to the cloud, and they had problems with like spammers and stuff. So they actually just went down for like a year. And so I was using this benchmark.js library just in the Node REPL. So does everyone know what a Node REPL is? One person, cool. Just super small again. So if I have Node installed and I type in Node, then I get the Node REPL, and I can just type code here, right? And then cool. So I can actually run JavaScript in my terminal here. So that's a Node REPL. And so I kept just doing that. So whenever I'd like, oh, I want to test this against that, I just write a script on the fly. It was becoming a pain. Okay. And I just, more recently I just wanted to modernize it, rewrite the React, add a bunch of features. Cool. So, how? So the Monaco editor, this is actually really cool. So you have almost all the features of VS Code in the browser. So it has IntelliSense. It has, let me just jump back to it. Go to some of these so you can see these a little bit better. So if I want to, if I have my string equals, I just have a bunch of code here. Oops. And I want to, rename my string. There's some bugs. Let me try that. Come on. It's so fresh. Come on. I think it's like Command F2 or something. Okay, go away. Function. Command F2. All right. We do things like you can multi-cursors and go to reference. You can just. This is totally normal. Okay, here we go. We do go to symbol if I want to search for whatever there. It's not working right now. Do format document. Anyways, lots of cool stuff. And in React. Questions about that? Yes.
So you said it's in React. How are you grabbing? Like, how's it delivering and receiving information that you want outside of React?
So I'm being a little deceiving about that. So Monaco editor isn't written in React, but I'll just show the code really. So I have my editor. I'm gonna make this a bit bigger. I'm actually using hooks. Is that?
I literally said hooks.
Oh yeah. So I just wanted to try out hooks. I just import Monaco editor here, and so it so this use effect with an empty array at the end of it is essentially a componented mount. So on componented mount, I just call Monaco editor create, which just adds Monaco to the DOM, and then you grab an instance using React use ref. So you have a reference to it on the DOM, and then you can just call functions to it. It exposes functions like setting the theme, grabbing the content out of it. So whenever you hit start benchmark, I just go to every one of them, grab the content out of it, and then run that benchmark.
So for use effect, are you getting any other benefits from than component mode, or is it just kind of like an exercise?
Yeah, I just want to try it out. I don't know how I feel about it.
Did you test the performance yet?
No.
Somebody wants
Okay, so the awesome thing that did not work because my internet's all funky. Let's just try it again. No, I don't want to. Okay, I don't want to refresh it. Let's try it. Okay, I have internet. Yes, it's loading. Okay, so I can actually call lodash.find. Let me just write some code here. I just grab an array, put the array up into my setup, and I can find my array. I want to find value. Value is cat. I can't type all of a sudden. Whoops. And that would actually run. So let's actually do something cool here. Oops. Let's pull in underscore. I'm going to run a few scripts here. I'm going to call this one Lodash. This one's underscore, not that anyone uses that anymore, just whatever. And this one's just javascript.find. So I'm going to do the same thing here, underscore dot find my array, and then I want to find value cat. And the same thing over here, but I'm going to use just a plain Jane this array. Oops, my array. And autofills it. Dot find, and that passes in an item dot value cat. Who do you think's gonna win? Or does it not?
Lodash.
You think Lodash is gonna win?
Plain Jane.
Plain Jane?
No, it's Lodash.
Place a bet. The race is up.
No, it's Plain Jane. Plain Jane.
This is super thrilling, by the way, just watching.
Oh, my name.
Plain Jane. Plain Jane. Plain Jane!
31 times fast. So yeah.
So that's fun.
Oh,
Lodash.
so importing dependencies at runtime in the browser. This uses something called dynamic import. It's pretty new. It's a stage 3 proposal. It allows you to import modules at runtime. So if only Chrome and Safari support it right now. So if anyone tries to sell Firefox, it doesn't work. But Firefox, it is coming soon. Even Opera supports it. But there's another browser I'm not even going to mention. Obviously, it doesn't support it. So it does support things. So the way you use it essentially is it just returns promise, and you can import. So I'm actually importing a module from the web. So, there's this CDN called JSPM, JavaScript Package Manager, and that one only exports modules. So it works great with this. They don't recommend, and I wouldn't recommend actually using this in production, like pulling your dependencies from the internet at runtime. Kind of weird. But this does allow you to do some cool stuff like, we're going to get into it soon. So if you wanted to deliver ES6 code to modern browsers, but an old code to older browsers, then you could do that with this. There's actually a tag you can add to say if this browser doesn't support dynamic import, then just load this code. Otherwise, load this code. Does that make sense? Cool. Benchmark.js, just a benchmarking library. It is actually pretty cool. So it uses code injection you're just typing text on the screen, and it uses code injection to actually turn that into a function and then run it. I think that's what XSS uses, like a cross-site scripting attacks. It's totally safe. And it just runs it a whole bunch of times, and then returns you a bunch of statistics about how it ran. I'm only exposing how many hops per second and how much faster it is, but it returns a bunch of stuff. I don't even understand. And next thing is Babel. Okay. I always pronounce it wrong. So I forgot to ask. Everyone here, I'm assuming everyone here has used React before. Who hasn't used React? I know you have. Okay, cool. So you've probably seen Babel before. And does everyone know, I'm not going to get you to put up your hands, but I'm assuming not everyone knows exactly how it works, so I'm just going to go over it really quickly. It's essentially a compiler or transpiler. It takes modern JavaScript, it does support TypeScript as well, and then turns it into old, one of the things it does is turns it into older JavaScript that you can run in other browsers. So React uses this to transpile JSX into JavaScript, so we're all using it, whether we like it or not. And so one thing to think about is if we're using, and I think we probably are, using modern JavaScript a lot, things like the spread operator. Older browsers don't know about the spread operator, so they're not actually running that. One thing to think about, and then not always, like spread is awesome, love it. But once you compile for older browsers, it's a lot slower. So I'm just going to show that off really quickly. I had a, yes. Let's just do, let's do inserting into an array. So we've all probably seen something like this. Let me just get rid of this stuff. Wait. Okay, I'm going to go here. I'm going to get rid of those scripts, get rid of my dependencies. I'm going to add a new script. And this is insert using spread. Is that? Do you read that? No? Okay. So this is actually one of the, oh my gosh. Okay, this is one of the recommended ways, or Redux recommends inserting item into array at a specified index like this. So essentially, you return a new array, you spread out the first part of your existing array, you add your item, and then you spread out the remaining part of your array and add that on the end. But another way to do it, that is, I'm going to zoom out a little bit. There we go. So I'm going to do insert using slice. This is also another recommended way for Redux anyways. So unfortunately if I zoom in it doesn't really show anything. You have to read that, just that sliver. So this does exactly the same thing, just a slightly different way. So it makes a copy of the array using array.slice. So if you don't pass any arguments to slice, it just copies the array. Then you use splice to add an item to the array at a certain point, and that actually does change the new array reference, or not the reference, but it changes the new array, and you just return that. But that's okay because it's a new reference. So they both do the same thing, and we're going to run that benchmark. Blah, 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 and wait.
How many times is it running?
10,000 times. So slice is a little faster, but within the margin of error probably is 1.4 times faster. Whatever. Spread's awesome. So I've actually added this feature that you can transpile your input using Babel for older browsers and then run the benchmark against that. So I have this janky little settings in the corner here. I just threw this together. And if anyone's configured Babel before, you specify a target. So it uses the preset env plugin, and by default, the target's very similar to this. So it supports any browser with more than 0.5% of the market, and don't support any dead browsers. So that's by default. If you haven't set your target, that's probably what it's supporting. And you can change that. You can say, oh, I only want to support Chrome and Safari and Firefox, or I want to support browsers with 20% market share. all that cool stuff. So I just checked that box. Run the benchmark again. Oh, and I didn't show this, but you can actually see the code. If you expand these, you can see the code it actually ran. So I'll go back. If I run the benchmark and open this back up, you'll see that that spread changed into this. So anytime you use spread, it actually turns into whatever that is. So it's a lot different. Now it's 4.5 times faster. Still not huge. It's best I could come up with. But it's an interesting thing to think about is that so the code you're writing if you're using these new features, it's actually being transpiled into older JavaScript to run on older browsers. I think that was it for Jesper. Yeah, like I mentioned, please try it out if you want. I'd love for people to contribute, submit issues to GitHub. And come talk to me on it. Oh, yes, question.
Can you go back to the Babel transpiled code?
Yes.
The insert using spread?
Sorry, where was it? It was here.
Yeah. Does it rerun all that code of defining the functions, or does it just rerun insert item?
That's a very good point. It reruns all that code every time. So if I were to take, actually that's a really good point. So we could rerun this again. I could take this code, insert it into my setup, which isn't counted in the actual time that it takes to run this.
And then copy insert item into another.
Yes. So I think, yeah, so we'll just get rid of this, right? And I'll turn off Babel. Okay, so remember that. It's a little under 3 million miles per second. What's going on again? I would imagine it's a little faster because it's not defining all this.
I'm curious.
3.5.
Yeah.
Yeah.
Because like those, that would only happen once if I was using Babel on my entire project.
Yeah, totally. So, yeah, it's a little closer, 3.68 times faster. And I'm totally not saying don't use spread because it's using splice is 3.5 times faster. Don't.
Do you think there's a way that you could write this to have the setup extracted?
Sorry, I'm not repeating the question. So the question was, do you think I could write this to have the setup code extracted?
Babel setup code.
So I do actually transpile the setup code as well, but it's not included in the results, so I'm not sure now that. You can contribute though.
I think you can do it.
Okay.
See if I do okay.
Any other questions? Yes.
Is there a way of importing different versions as dependencies?
Yeah, so the question is, can you import different versions? And right now, no. I can actually show up, if I still have internet, I could show up this gspm.io. So honestly, I don't think it's super supported anymore. But it was an easy way to just get modules exported. So if I actually just grab this URL here and show you that. So I just say, I want to get the React dependency from gspm.io. Internet, come on. Okay, well, it would look something like export default, and then it would export default React, and it would point to a specific version of the React dependency. It's just the most recent version that GSPM published, and then it would have export all of React's dependencies. So you can, using dynamic import, you can import any code as long as it's exported as a module, but not with this. Okay. Another question? Yes.
Did it unload those dependencies? Like actually?
It
Or if you
did,
called
so,
Modash? What would happen? Like if you go back to the window where you had Lodash
So yeah,
and just
it
try to
would
use
not work.
Lodash.
So it actually just throws it into window.lodash. So that's undefined. And then hopefully this still works. No.
Is that the one where you had Lodash? That's the one you had Lodash
Okay,
in.
so let's do this again. Ignore that. That's totally fine. Ignore that. Window.lodash. Okay, so it's undefined, and if I add it now, okay. But it is cached though. The browser still caches it, but now it is in the window. Global windows.
Cool. So there's like an unmount.
Yeah. But the browser still has it. Questions? Yes.
So I like that this seems really cool. I also don't know when this would ever be used. It's like, yeah, it's awesome that something works 3 million times versus 10 million times, but I'm never using something that many times that I know of. So
Yeah.
how can we bridge that gap between me understanding like proper performance and when to use this on a single function versus, I'm just splitting hairs?
That's a really good question, and my examples were horrible. Let me think. So, yeah, it really comes up to when you're developing a new feature or something like that, and you think that this is going to be a performance bottleneck. So, for example, in our application, we recently can't talk too much about it, but we did something like we pulled down possibly thousands of items, and then each item is tagged with possibly 10 to 100 things each. And we're paginating that, but as we're paginating that to memory, we want to basically create like a tag map of all the tags we have. So that can get a little expensive to just every time there's a component to update, or whenever we get new information from the server, we're going through all the items we have loaded in memory, pulling in all the tags, deduping them, counting them, something like that is where you might want to look at something like this. Or if you're just bored.
We use it all the time at work, actually.
Yeah.
It's like, hey,
I don't know if we
let's
need
check
to,
it out.
but I think one of the things with React is that, and I talked about the last talk, which is about jankiness. And React does an awesome job at not being janky, but it's never clear when, oh, now I have a problem with jankiness, right? If you do, I mean, that's really bad. But, things just may become a tad slower, and just keeping it in mind, like, I like to just do this in my spare time kind of thing. Super interesting. And then next time I need to check if O is in hello world, okay, find index is a little faster. Any more questions for you all?
Instead of just printing out this stack.
Good.
Cool. Thanks, guys.